Welcome back to our next lesson in our beginner Golang programming series. Today, we're diving deep into a fundamental concept that is essential for every programmer to grasp: functions. Functions are like the building blocks of any program, enabling us to write efficient, organized, and reusable code. Functions allow us to break down or refactor our code into smaller, manageable chunks, which not only makes it easier to read and understand but also to test. Imagine you're working on a large project with hundreds or even thousands of lines of code. Without functions, your codebase could quickly turn into a chaotic maze. Functions provide a way to compartmentalize your code, grouping related tasks together. Functions also give us the ability to reuse our code. Imagine you need to perform a specific task repeatedly throughout your program. Instead of duplicating the same code multiple times, you simply create a function to encapsulate that task into a single, well-defined entity. This not only promotes better organization but also ensures that any future changes or improvements can be made in just one place. Let's start by looking at how to define and invoke functions. In Go, a function is a named block of code that performs a specific task. It's like giving a name to a set of instructions for your application to execute. In the example below, we have a function. We start with the func keyword, followed by the function's name. Then we have a pair of parentheses where we can pass parameters to it. Then finally, we enclose the body of the function in curly braces. The body is where the code to be executed by the function will lie. In this case, it will print, "Hello, world," when it is called. We can execute or call our function by simply calling the name of the function, followed by a pair of parentheses. Let's change this a little. We can pass values to our function by adding them within the parentheses, and then passing the value when we call the function. Now consider the code execution flow within functions. When you call a function, the program jumps to that function's code, executes the instructions, and then returns to where it left off. So, in our last example, call say hello, Alice. The say hello method is called, and the string Alice is passed to it. The program executes the say hello function's code within the body of the function and then continues with the main function. This way, you can create functions to perform specific tasks and reuse them throughout your code, making it more organized and easier to manage. Remember, functions are like mini programs that help you break down big tasks into smaller, manageable pieces. It's a good idea to refactor your code once you have things working. It may be possible for you to extract out a few functions to make your code cleaner and easier to read. Think of function parameters like giving ingredients to a recipe. When you cook, you need certain ingredients to make a dish. Similarly, when a function needs some information to do its job, we give it those details using parameters. In this example, the print details function takes three parameters of different types: a string, name, an integer, age, and a floating point number, height. When you call the function in the main function, you provide arguments that match the types and order of the parameters. Remember, the key is to ensure that the order and types of the arguments you pass match the order and types of the parameters in the function definition. Return values. Getting back results. Imagine you're baking a cake. You put ingredients in, and the result is a delicious cake. Functions work similarly. We can get something back from a function after it does its job. We call this the return value. To send back a result from a function, we use the return statement. It's like giving back a finished cake after baking it. Let's create a function that adds two numbers and returns the result. First, we create the addNumbers function and have it accept two parameters of type int. It has a return type of int as well. Within the function body, we add the two parameters together and store them in the sum variable. We can then use the return statement to return our sum back to the main flow of the application and print it out to the user. Variadic functions are like having a pizza that can have any number of toppings. In programming, they allow you to pass a variable number of arguments to a function. It's like making a recipe that works for any number of ingredients. To create a variadic function, you use the three dots before the type of the parameter. Inside the function, you can treat the variadic parameter like a slice of values. More on slices in an upcoming video. Example. Adding numbers of your choice. Let's create a function that adds any number of integers and returns the total. In this example, the addNumbers function can take any number of integers as arguments. You can pass as many or as few numbers as you want, and the function will add them up. Within the body of the function, we use the range form of the for loop to iterate over a slice of numbers that were passed to our function and add them up. When learning a new skill, it's hard to know how to know if you have understood it correctly. So at the end of every lesson, I'm going to give you a short assignment. It should help you test to see if you have understood what we have talked about. The following video in the series will be me walking you through the assignment. So stay tuned for that. Anyway, here is your assignment. Write a calculator program, support addition and subtraction at the very least. Bonus if you can figure out how to do it using a single function. Come back and check my next video where I will walk you through creating this program. That's a wrap for our lesson 4 on functions in Go. You've learned about why we use functions, when to use them, how to create and execute them. Also how to pass parameters to them and get values returned from them. Please remember to like and subscribe if you enjoyed this video. Until next time, happy coding!